In this video, we are still looking at the sum to infinity. All right. Remember, ladies and gents, when I see sigma, I'm seeing sum, right? I know that I have to use the sum formula, right? Because of sigma. Yeah? And then because of infinity, I know that I'm going to be doing sum of infinity of a geometric number pattern, right? Why? Because this is the Tn formula for geometric. All right, so let me write down the formula that I'm going to use. A over, let's see, is going to be 1 minus r. Né? Awesome. And then they want me to determine the possible values of a and r if the sum to infinity is 5. Okay, so in this case, they gave me what the sum to infinity is. So the sum to infinity is 5. Okay, so I know that I'm going to substitute 5 on the sum to infinity. Okay. And then let's see now, ladies and gentlemen. So we're going to say 5, which is the sum to infinity equals to a over 1 minus r, right? And then you can see that the question says they only need the possible values. So it means we are going to end up with an inequality. Né? Inequality, basically. We're not going to get exact values. No, we're going to get a range of possible values, right? So here, the best thing to do would be to simplify, to remove this fraction. So I'm going to say, okay, this is over 1. So I'm going to multiply this there. So 1 minus r. Then you multiply this one here. So a times 1 is just a, right? And then you FOIL here. You have 5 minus 5r equals to a, right? And then you do this. You say, okay, 5 minus a is equals to 5r. I'm sure you see what I did there. You take a this side, you take 5r that side. Then you divide both the sides by 5. And then therefore, r will be 5 minus a all over 5. Now we can answer the questions. We know that possible values of r, né? Possible values of r are going to be this, right? Is going to be in between that for this to be true. We must have convergence. We must have convergence for the sum to infinity to exist. So we gave the possible values of r for this question to be true. Possible values of r is between -1 and 1, excluding -1 and 1. So it's 0 point something, we know, for us to have sum to infinity. Then we can easily get the possible values of a by substituting r into here. Therefore, we have -1 is less than 5 minus a over 5, which is less than 1. Remember, this is our r. So you can replace r with that because they are equal. And then I'm going to remove the fraction by multiplying by 5 both sides. So here I'm going to have -5. It's 5 minus a, which is less than 1. I mean less than 5, right? We times by 5 that side as well. And then what does this give us? We're going to have this. I'm going to minus 5 both sides. So here I'm going to have 5, I mean -5 minus 5. Then here I'm left with minus a. That side I have 5 minus 5. This side I get -10 minus a. Then you have 0, right? But we cannot have a negative there. So I'm going to switch everything. So this will be positive 0. Remember, 0 is just neutral, right? And then this is your final answer. But someone can say, okay, let's start with 0 and then put 10 this side. Our a is in the middle. We can see that a is less than 10. So a is less than 10. A is bigger than 0. So a must be bigger than 0. And then we have that as your final answer. These are the possible values of a. And then those are the possible values of r for us to have the sum to infinity, okay, of 5. All right, now let's do the last question in this case. So this question here, they say, given the series 18, 6, and 2, then to infinity. So we're adding them infinitely. Find the sum to infinity if it exists. So guys, to check if the sum to infinity exists, we need to check if this is geometric. That is the first thing. And then we need to check also if R is in between there. If the R is not in between that interval, we don't have convergence. So sum to infinity does not exist. So those are the two checks that we are going to make. Ne? Okay. So obviously to check if it's geometric, we need to check T2 over T1. We need to check T3 over T2. If these are equal, then we can conclude it's geometric. So it's 6 over 18. Then here's going to be 2 over 6. Here I can see I get 1 over 3. Also, here I get 1 over 3. Therefore, we can see that your R is 1 over 3. Therefore, this is geometric, right? Because the ratio is constant. So you have a right to call it R, geometric. And then you can see that, therefore, your R is in between this interval, right? Then you can do sum to infinity if your R is in between. If R is outside, it's divergent. You can't do sum to infinity. So in this case, our sum to infinity will be A over 1 minus R. Our first term is 18. And then you have 1 minus 1 over 3, which is your R. And then sum to infinity is 18 over 1 minus 1 over 3, which is 27, right? And then this means that no matter how many terms we add on this series, we are always going to be approaching 27. Ne? We'll never surpass 27. So you're going to get 26.999999 as you add to infinity. Right, ladies and gentlemen. Please don't forget to share, leave a comment, and like the video to make it reach more people. Thank you very much for watching the video. I hope it was helpful. Aluta continua. Tango.